Hello everyone. The majority of today's lesson will be spent going over AP practice problems that I assigned last week. So the first two we're going to start with, these were assigned on Wednesday. So go ahead, take a look. These are pages 10 and 11, problems 36 and 38. If you got these right, great job. But still continue to look, because maybe you may have been thinking about something a little different. That still got you to the correct answer. But let's take a look at 36. We're given f of x is equal to this piecewise function, and we need to figure out which of the following are true. So for the first option here, the limit of f of x as x approaches 1 exists. Well, let's take a look at this. You could either take the time to graph this, or we could just take a look to see if the left-hand limit is equal to the right-hand limit. So the left-hand limit is just going to become the 3 times 1 squared minus 4, and then the right-hand limit is 6 times 1 minus 5. So this is a negative 1, 3 minus 4, and then 6 minus 5 will give us a positive 1. So in this case, the answer is no. Option 2 here, the limit of the derivative of f of x as x approaches 1 exists. Well, let's go ahead and write out an equation for the derivative, which means we're just going to take the derivative of each expression here. So we're going to get a 6x for x is less than or equal to 1, and then just a 6 for x is greater than 1. And again, we'll see if the left-hand limit is equal to the right-hand limit. So the left-hand limit when x is 1 is just going to be 6. And the right-hand limit, well, that's just a constant, so that's true, so we would say yes. Now in this third question, we need to know if the derivative, if f prime of 1 exists. And for that, we're going to take a look at the graph. So we're going back up to here. So if we go back up to these values right here, being that the limit doesn't exist, we would say no to this as well, because f of x is discontinuous at x equals 1. And again, it's because we're jumping from this value of negative 1 as we're approaching 1 from the left up to a 1. We're approaching that from the right. So the correct answer here is 2 only, which is giving us B. All right, let's take a look at number 38. Here we're given the function f of x is equal to e to the x minus x cubed. We're asked how many critical points. So we start by, we don't actually have to find maxes and mins here, but we start the same way. We find our derivative. What's the derivative of e to the x? E to the x minus 3x squared. And then we'll see where this is equal to 0. It's never undefined, so we don't have to worry about that. But yes, we can use our calculator, so use the solve feature. And we should get 3 values here. A negative 0.59, 0.459 rather, 0.910, and a 3.733. So the correct answer is 3. That was D. All right, next let's take a look at the free response question. That was off of page 156, number 5. Again, I'm going to show you the point values that correspond with each correct answer here. All right, so for question A, we need to show that dy over dx is equal to y over 2x minus 2y minus x. So we want to just use implicit differentiation to solve for y prime, which is also dy over dx. So we're going to start by taking the derivative of each side with respect to x. So just like with related rates, we can go ahead and write this as dy over dx if you want to. So first we're going to get a 2y times y prime, or times dy over dx, is going to equal, the derivative of 2 is just 0, and then we have to use the product rule here. So we're going to get uv prime, so that's x times dy over dx, plus y times 1, so just y. Now I want to move all my dy dx terms over to one side, so we'll have 2y times dy over dx. Again, you can use, should be a dx there, you could use y prime, minus x times dy over dx equals y. We'll factor out a dy over dx. We'll get a 2y minus x is equal to y. And then dy over dx is going to equal y over the quantity 2y minus x. So for doing all of this work, you would get 2 points. All right, for question B, find all points x, y on the curve where the line tangent to the curve has a slope of 1/2. So all this means is we're going to set our derivative equal to 1/2. So we just take y over 2y minus x, set it equal to 1/2. We're going to cross multiply here. So 2y is going to equal 2y minus x. I subtract 2y, I'm just going to get x is equal to 0, or negative x is equal to 0, and divide by that. So now I go back up to my function. So if we're at y squared equals 2 plus xy, and x is 0, we get y squared is equal to 2, so y is equal to plus or minus radical 2. So again, all points x, y on the curve where the line tangent to the curve has a slope of 1/2 is 0, negative radical 2, and 0, positive radical 2. And we get 2 points for this. 1 point for the work, 1 point for the answer. Let's go back up to part C. Show that there are no points x, y on the curve where the line tangent to the curve is horizontal. So for part C, we're going to take our derivative, y over 2y minus x. If it's horizontal, that means it's going to equal 0. So if I cross multiply here, I'm just going to get y is equal to 0. Then if I go back to the curve, which is y squared equals 2 plus xy, I'm going to get a 0 is equal to 2, which doesn't make any sense. Therefore, the curve has no horizontal tangents for any x value. So this is worth 2 points. You get 1 point for solving for y and 1 point for this explanation over here. So you want to connect the two. All right, and then question D. Let x and y be functions of time that are related by this equation. At time t equals 5, the value of y is 3 and dy over dt is 6. Sounds like this is a related rates question. Find the value of dx over dt at time t equals 5. So let's break everything down other than having a picture here. We know we have our equation. We know that dy over dt is equal to 6. We want to find dx over dt when t is equal to 5. So our equation, y squared equals 2 plus xy. And we know when time t is 5, the value of y is equal to 3. So we want to find dx over dt when t is equal to 5. Now what we found earlier was dy over dx. This is dy over dt, so we have to do a little bit of extra work. But dy over dt is equal to dy over dx times dx over dt. So dy over dx, that's that y over 2y minus x times dx over dt. So we know dy over dt is 6. We have these two up here, but guess what? We also have an x in here, so we need to find x as well. So before I do anything else, I want to come back over here. When t is 5, y is 3, so I could use my 3, y is 3 to help me find x. So this is going to give me 9 minus 2 will give me 7 equals 3x, so x is going to equal 7/3. So now I can finish this. So we're going to get y, which is 3, over 2 times y, so that's going to give me 6 minus 7/3 times dx over dt. So we're going to get 6 is equal to 3 over, we could say it's 11/3 times dx over dt. We can multiply by the reciprocal here. So we're going to get 9/11 times dx over dt. And then we can multiply by that reciprocal. So we're going to get 66 over 9, or we could say dx over dt is going to be 22 over 3. So there's a lot to do on part D here, but here's how the points break down. We can get 3 points altogether. First is just solving for x. So you could get 1 point over here just for solving for x. Another point, they say using the chain rule, but it would just be this work that's over here. So we'll say using that dy over dt, and then a point at the end for the answer. All right, next I'm just going to show you the answer to yesterday's assigned AP problem. Now you are allowed to use a calculator on this, so if you did not get D, go back and try this again. And since I ended up taking the AP practice problems just for a completion grade, I do want to go over these. I'm not going to go over all of them right now, but I'll go over about 4 of them. Please make sure you correct these, though, as you go over them. All right, so for number 1, we're given the limit as h approaches 0 of cosine of 3 pi over 2 plus h minus cosine of 3 pi over 2 all over h. Now, we don't do anything with this limit notation. We don't want to do any work with it, trying to expand it, nothing. What we're gathering from this is that this is the limit definition of the derivative. So this is all equal to f prime of x. So if you recall, remember that's the limit as h approaches 0 of f of x plus h minus f of x all over h. So guess what? Whatever's over here, that's our f of x with a value substituted in. So this becomes, that means f of x is really cosine of x. And now we know the shortcut, the rules, derivative rules of trig functions to help us find f prime of x, which would become a negative sine of x. And the value is a 3 pi over 2. So this becomes f of 3 pi, f prime of 3 pi over 2, which is equal to the opposite of sine of 3 pi over 2. Now we just need to remember what sine of 3 pi over 2 is. So if we go back to our unit circle, 3 pi over 2 is down here at 270 degrees. The ordered pair here is 0, negative 1. Sine is our second value, so it's the opposite of negative 1, which is positive 1, and that's A. Okay, for number 2, it tells us if dy over dx is less than 0, and our second derivative, using this notation here, is less than 0, then what point on the graph is the only point where this is true? So this is telling us that our function, we'll just go back to y, this means our first derivative is negative, so this means y is decreasing. Over here, our second derivative is negative, so this means y is concave down. If you go back to the graph, this happens at point B. That's the only point where the graph is decreasing and is also concave down. Number 3 is another good one to go back over for implicit differentiation. We're given y cubed x plus y squared x squared is equal to 6. We want to find y prime at 2, 1. So carefully using implicit differentiation. We have to use the product rule twice here. So I'm going to call this uv, I'm going to call this uv. So uv prime, and if you need to, write it out just for this first part. So u is going to be y cubed, v prime is just 1. I don't have to write that. Plus v, which is x, times u prime, which is going to become 3y squared times y prime, or dy over dx. Next, I'm going to look at this again as uv prime plus vu prime. So uv prime is going to become y squared times 2x plus v, which is x squared, times u prime becomes 2y times y prime, and then that's going to equal 0. Now, I don't want to have coefficients in the middle of my expressions here, so I'm going to rewrite this. This is y cubed. I'll move the 3 out in front, plus 3x y squared y prime. I'll move the 2 out in front, 2xy squared. And then I'll move the 2 out in front here, 2x squared y prime equals 0. It's always good to double check this before you move on. So I'm just going to leave these two terms over here. So we'll get 3xy squared y prime plus 2x squared y prime. It's going to equal negative y cubed minus 2xy squared. Then we'll factor out a y prime, and we're left with 3xy squared. And it's very easy to overlook an exponent, so always make sure you've got all the parts, all the pieces here. Then plus 2x squared y. And then we'll just divide. So y prime is going to equal negative y cubed minus 2xy squared over 3xy squared plus 2x squared y. Now, if you wanted to, you could factor out a y, but we're just substituting in numbers. So it really doesn't matter if we simplify that any further. So again, we're looking at 2, 1 very carefully. So we're going to get the opposite of 1 cubed minus 2 times 1 squared over 3 times 2 times 1 squared plus 2 times 2 squared times 1. So up top, we're going to have a negative 1 minus 4. In our denominator, we'll get a 6 plus 8. So this will give us negative 5/14. And that was answer C. All right, we'll go over one more, number 5. Now, sometimes, again, based on these answers, we don't really need to do the entire problem, but I'm still going to show this to you. So we're given f of x is equal to x to the 4th minus 2x cubed. The question was to figure out the number of points of inflection and relative extrema here. So what we first want to do is find our first derivative. So that is 4x cubed minus 6x squared. And then we also need to find our second derivative. So then that becomes 12x squared minus 12x. All right, so to find our relative extrema, we're going to set our first derivative equal to 0. It is not undefined anywhere. So as we do that, we can factor out a 2x squared. And we're left with 2x minus 3 equals 0. So x is going to equal 0, and x is going to equal 3/2. So we make our first derivative number line. And again, I'm going to go back up to the factored form here. So if we're at negative 1, this would give us negative, because this will give us positive and a negative. In between 0 and 3/2, we're going to get another negative. So that means we do not have a relative extrema at x equals 0, but anything greater than 3/2 will be positive. So f is decreasing, decreasing again, and then increasing. So right here, we have a relative min. Right, as I was overlooking some of your papers here, I saw, again, with the second derivative, just be careful. Some of you forgot to write this extra x here. So I'm sure if you had that in there, you definitely would know what to do. We need to factor out a 12x, and then we're left with x minus 1. So our critical numbers here are 0 and 1. So we're going to make our second derivative number line. And again, I'm going to substitute back into the factored form. So if we're at a -1, we're going to get a positive value here. Let's say we're at a 1/2, we're going to get a negative, and then if we're greater than 1, we'll get a positive. So f is concave up, concave down, concave up. So we have 2 points of inflection and 1 relative extrema. But I believe the answer's only limited. I think there was only one choice that had 1 relative extrema. So again, if you find one answer and it's enough to do process of elimination, by all means do that. So the correct answer here was C. All right, so like I said, tomorrow we'll continue going over 6, 8, 11, 17, and 19. I did number 9 in one of the videos last week. So please let me know if you have questions as you're working on this. Part of today's assignment will still be to go back over these problems here. I do want to talk about yesterday's problems 31, 33, and 37. Sketching a graph is going to help out greatly. So make sure you sketch the graph. If you still have questions over that, please email me, let me know. I will go over those, or at least show the solutions and my graphs with the explanations tomorrow. The quick review 1 through 9 odd, this was just looking at taking the derivatives, but I do want to talk about number 5 and 7. So 5 was y is equal to the natural log of secant x plus tangent x. It's been a while since we worked with derivatives of natural logs, but y prime, the derivative of the natural log, becomes 1 over whatever this quantity is. Then applying the chain rule, we have to take the derivative of the inside stuff. So the derivative of secant x is secant x tangent x. And then the derivative of tangent x is secant square x. So that's number 5. Now we could go further and try to simplify this. Because if the answer in the back of the book was a little different, I believe it may have just showed secant x. So let's see how that could work out. So we could just factor a secant x out of the numerator here. And then we're left with tangent x plus secant x, which will divide with the bottom part. And this will just leave us with secant x. Also want to take a look at number 7. We're given y is equal to x to the n plus 1 over n plus 1, where n is not equal to -1. So we want to find y prime. So let's use the quotient rule here. So we have our low d high becomes n plus 1 times x to the n plus 1 minus 1 minus high d low. Well, this is just a number here, so that's just going to be 0 all over the quantity n plus 1 squared. So this whole part goes to 0. And now we're just left with, really, I could write this as n plus 1 squared times x to the n over n plus 1 squared. Now those n plus 1 squares can cross out, and we're left with x to the n. And that's going to come back to play in today's lesson. All right, so as far as exercises 1, 3, and 5, like I said, check your answers in the back of the book, continue working on those, and let me know if you have any questions. All right, so to finish up today's lesson, we're going to do some investigating on the Inspire. All right, so when we just see this symbol without the limits of integration above and below, we call this an indefinite integral. So this is what I want you to type into your calculator. We want to evaluate this indefinite integral of x dx. So you still go to menu 4.3. You could just skip over the boxes for the limits of integration. Just leave them blank. So just type in the integral of x dx and see what you get. We should be getting x squared over 2. Let's try the integral of x squared dx. So pause the video, go ahead and type that in. We should be getting x cubed over 3. Let's try this one more time. Let's do the integral of x cubed dx. And once you type that in, we should be getting x to the 4th over 4. So what I want to do is actually just take the derivative. So if I write this, so let's let y equal 1/4 x to the 4th. Let's find y prime. Well, that's going to become 4 times 1/4, which is just 1. And it looks like I get x cubed. So we've been doing this before. If we were just looking at just an x, what did we call that in the past? If we're getting an x squared over 2, that would be the antiderivative. So we'll say, therefore, the integral is, or means, for us to take the antiderivative. So here's a general rule. If we have the integral, we call this the power rule for for integrals or antiderivatives. So if we have the integral of x to the n dx, we do the opposite. Instead of multiplying by the exponent and subtracting 1, we divide by the new exponent. So first we add 1 to the exponent, and then we divide by whatever that power is. Or a lot of times, if our exponent turns out to be a fraction, we multiply by the reciprocal of it. Now this only works as long as n is not equal to -1, and we're going to see why here in a moment. So we say this is the power rule for antiderivatives. Now we also want to just show that plus c. So this is going to be x to the n plus 1 over n plus 1 plus c, as long as n is not equal to -1. Because depending on the function we're given, we can't always use this power rule. If it's not of the form x to the n, we can't use this power rule. So let's just wrap this up with 3 more examples. I'm sorry, 4 more examples. They're not going to take too long. So if we have the integral of x to the 5th dx, without using the calculator, let's just apply the power rule. This should turn into what? X to the 6th over 6 plus c. The integral of x to the -2nd dx. Remember, we can use this power rule as long as the exponent is not -1. So this becomes x. If I add 1 to a -2, it's -1 over -1 plus c. But we want to make this look a little bit nicer. So we say -1 over x plus c. And now we've seen this before. The integral of sine theta d theta. So what is the antiderivative of sine theta? Meaning if we took the derivative of this function, we would get a positive sine theta. We should be thinking cosine theta, but remember the derivative of cosine theta is a negative sine theta. We need that negative to go away, so it should be a negative cosine theta plus c. And our last example, the integral of x to the negative first dx. What happens when that exponent is a negative one? We can't apply the power rule. Why not? Because we'll get x to the 0 over 0. We can't let that happen. What we do is we rewrite this as 1 over x dx. Now there was something we just did, part of the quick review, at number 5, where we took the derivative of this one function and it became 1 over that quantity. If you recall, that was the natural log. But we need to make sure we're taking the natural log of something positive. So it's going to become the natural log of the absolute value of x plus c. So when n is -1, the antiderivative of x to the negative first then becomes the natural log of the absolute value of x plus c. All right, so still continue to go back over yesterday's assignment. Double check, correct, ask me questions. And now I'm going to give you guys gift 5-3. I'll have it scanned in as a separate post. But even if you print this out, please do all work on a separate sheet of paper. Now for the last 3, I want you to graph these by hand and use the area to help you figure out the integrals. So the last 3 are definite integrals, but the first 15 are indefinite integrals. We're just finding the antiderivatives. Keep the plus c at the ends of each answer. Let me know if you guys have any questions.